Hello class and welcome to another exciting facilitation for this semester. I am Dr. Annie George, Department of Public Health, Faculty of Health Sciences, and will be your guide. Hope we all enjoy it. Thank you.
So on today's topic, topic 5 this week, we'll be looking at variables and classification of variables. At the end of this lesson, we're expected to know what variables are and see how we can classify them appropriately, as well as understand calculations in screening tests from the previous class. Like I said from the previous class, you can look at the screening tests, the confirmatory test, total, positive result, negative result, and then you can see what the table shows on the confirmatory test level: the true positive, false negative, true negative, and then the totals. We will use this to go further in our discussion. So like I said, the details of the table: A is true positive, B is false positive, C is false negative, D means true negative. Sensitivity is the probability of a positive test in people with the disease, which is A over A plus C from the table, and specificity is probability of a negative test in people with the disease, which is D over B plus D. We will go into an activity now to do the calculation proper in the next slide. So activity 1, calculation of sensitivity and specificity. The question says 200 Nigerians were tested for COVID-19 virus. 160 of them tested positive. 200 were tested for COVID-19. 160 of them tested positive. Why 10 persons were true negative for the test? 20 were false positive. Number 1 is calculate the probability of a positive test in people with the disease, which is sensitivity. And then number 2 is calculate the probability of a negative test in people without the disease, which is specificity. Now you look at the hint on the first calculation, A over A plus C, and the hint on the second calculation, which is D plus B plus D. We will try to put the numbers in the table and see how we can calculate it. So look at the screening table and see how we're putting the numbers. The question says that 200 Nigerians tested for COVID-19. In that 200 that tested for COVID-19, 160 tested positive. That's what the question says. So if 160 tested positive, that means all the positive results total are 160. So you put 160, which is A plus B. Then if all the positive results are 160, it means the negative results are 40. So you put 40. That sums up to 200. Now, you now go further from the question. It says that 10 were true negative. So true negative, you go to negative and put 10 as true negative, which is D. Then 20 were false positive. You also go and put 20 that is false positive, which is B. So if you have 160 minus 20, which is A plus B minus B, you have 140. So you get true positive, which is 140A. If you have total negative as 40 and you have true negative as 10, if you minus it, you get 30, which is the false negative, C. So that gives us, all the values in the table. So if you add A plus C, 140 plus 30, you have 170, which is A plus C. If you add 20 plus 10, you have 30, which is B plus D. And then of course, A plus B plus C plus D is 200, which is the total. So to calculate the probability of positive test in people with disease is simply A over A plus C, which is 140 over 170, and that will give you 0.82 as the probability. And that translates to 82%. If you calculate the probability of a negative test in people without the disease, which is specificity, it will be D over B plus D, which is 10 over 30, and that will give you 0.33, and that translates to 33%. So we go into what is called predictive values. Predictive values simply means, using that table as well, positive predictive value means probability of a person having the disease when the test is positive. The probability of a person having the disease when the test is positive, and that is A over A plus B. Negative predictive value, on the other hand, is the probability of a person not having the disease when the test is negative, which is D over C plus D. In the next slide, we'll have another activity. Let's see how it goes. Okay, activity 2, which is calculation of predictive values. Number 1 says calculate the probability of the person having the disease when the test is positive, which is positive predictive value. And if you look at the table, A over A plus B, that is all the positive results. True positive over true positive plus false positive. That is what it means. And calculating the probability of the person not having the disease when the test is negative is negative predictive value, which is true negative over true false negative plus true negative. All the negative results. That is what it means from the table. So this is the answer. The probability of a person not have or of a person having the disease when the test is positive, positive predictive value, will be true positive over true positive plus false positive. That's all the positive results, which is 140 over 160, and that translates to 0.87 and 87%. And the probability of the person not having the disease when the test is negative, that's negative predictive value, will be true negative over false negative plus true negative, which is 10 over 10 plus 30, which is 10 over 40, and that translates to 0.25 and it's 25%. So with these calculations, this brings us to variables. What do we understand as variables? Variables are entities which makes individuals different from one another. That identity that makes individuals different from one another is variable. It could be measures, it could be quantities, it could be sets of values. 1, 2, 3, 4, 5. It could be non-measures as well, attributes like sex, male, female, religion, Christian, Muslims, and all that, Hindus. It could be outcome of a treatment that is termed variable. So how do we classify variables? Variables are usually classified as quantitative or qualitative variables. Quantitative variables are usually measurable variables. They are numerical variables, and they can be discrete or continuous. Discrete, when you're talking about population parity, the number stands out, like 1, 2, 3 are discrete. Continuous, like when you have weight, height, and age, especially weight and height, you can have somebody's weight as 20.5 kg, height as 10.5 centimeters. Because it is point, it's continuous variable. It's not like standing out on its own, discrete. So it can also be qualitative variable. Usually non-measurable variables are qualitative variables. They deal with attributes, categories, example, sex, marital status, occupation of someone, ethnic group, your Igbo, Hausa, Yoruba, Efik, Ibira, those are Fulani, those are ethnic groups, um, so they are regarded as qualitative variables. You can even classify variables further into what we call nominal variables, like exclusive and unordered. They stand alone, like blood group. Someone's blood group is O positive, AB, A or B. Those are nominal variables. Variables can also be ranked or ordinal variables, like 100 level to 200 level students. When you group them into that order, less than or higher than, that kind of hierarchy. It can also be interval scale. Interval scale is when the distance between points of measurement is fixed, like arbitrary 0 points. Like when you measure temperature, temperature can be below 0. It can be 0, it can be below 0. It can be minus. That is an arbitrary 0 point. But in ratio scale, there is no arbitrary 0 point. What you have is a true 0 point. Distance between points of measurement is usually fixed. It's absolute 0, like in height and weight. You can't have a value of somebody's height or weight below 0 or even 0. So that is what we call ratio scale. So in further classification of variables, we have nominal, ordinal, interval, and ratio scale. So in summary, in this topic, we learned what variables are and how to classify them. We have also looked at the calculation of sensitivity and specificity, as well as predictive values. In our next lecture, we will look at organization and presentation of data. Thank you for listening.